Hello, welcome to the course of IPv6. So today we are going to discuss about the multicast listener discovery and multicast router discovery. So in this chapter we will discuss about the multicast listener discovery, after that its version 1 and version 2 and their packet format, and last one we will discuss about the multicast router discovery. So first of all, let's start with what is multicast listener discovery. So here the multicast listener discovery is used by IPv6 devices to discover multicast listener in a directly linked network. So here the IPv6 multicast group here is a group of receiver that want to receive a particular data from a source address. So here this group has no physical or geographical boundaries, and here the receiver can be located anywhere on the internet or in a private network. So here this multicast listener discovery process is used to find out the listener that are sitting in particular geographical area or in a private network. So here the protocol independent multicast, that is PIM, is the routing technique that is used for forwarding multicast messages in a network. So there are two versions of MLD. The first one is MLD version 1, that is based upon the IGMP version 2 for IPv4, and it is defined in RFC 2710. So here the IGMP is the Internet Group Management Protocol version 2. And after that the MLD version 2 is based upon the IGMP version 3 for IPv4, and it is defined in RFC 3810, and its additional information is and the enhanced information is added in the RFC 4606. So these are the two versions of MLD version 1 and MLD version 2. So let's discuss about the first version, that is MLD version 1. This is the packet format of this multicast listener discovery version 1. So here it is consists of 32-bit long packet, and here it consists of type, code, checksum, and the next field is maximum response delay. The next field is reserved, and the last field is multicast address. So let's discuss about this field one by one. So first field is type field. So here the type field have a value. It can contain a value of 130, that will indicate a multicast listener query, and if it will contain a value of 131, then it will indicate that it has a multicast listener report, and if it will have a value of 132, then it will indicate that is a multicast listener done message. So here if it is a 130, it means it contain a value of 130 that is used by a IPv6 router. So here it made the query that the multicast address is over a link. So there are two type of queries here. The one is journal query and the next one is address specific query. Here if it is a journal query, it will determine the multicast address that have listener on a link. It means the listener is present over on the link, and we have to find out its multicast address. Here the multicast address field, if it is set to journal query, then here the multicast address field is set to 0. After that, if 130 value will contain a address specific query, then it will find out whether there are member for a specific multicast address over a link or not. After that, here the multicast address field is set to multicast addresses of a device for which query is done. Here there are two queries, one is journal query and another one is address specific query. So here if it is a journal query, then it will find out a multicast address of a particular listener that is present over the link, and if it is a address specific query, then it will find out the address of a member of a specific multicast address over a link. And after that the next value is 131. So here if the value is set to 131, then it will use it this packet is used by a listener, and it is used to register itself in a multicast group. It means it want to register itself in a multicast group. Next, second one is 132. Here the value is set to 132, and if it is set to 132, then it is used by or sent by a listener to deregister itself from a multicast group. So these two multicast listener report will request to add add the device in a multicast group, and if we will use multicast listener done, this message is used to delete itself from a multicast group. After that, the next field is code. So here the code field is set to 0 and it is ignored by the receiver, as it is sent by the sender, but it is ignored by the receiver. After that, the next is maximum response delay. So here it is used in query message only. So the maximum allowed delay is in millisecond, and the maximum allowed delay in which a node has to send a report if it has a listener. So this is a maximum response delay which is used by a listener, that it is used by a sender that will report. It is used by a device that has a report if it has a listener, and here in other messages this field is set to 0. The next field is multicast address field. Here this multicast address field is set to 0 if it contain a journal query, and it will set to multicast group address if it will contain a address specific query. So here in report or done message, this field contain either the multicast group to which a member listener is and or a group it is listening. So here these are the values of the multicast address field in MLD version 1. The next we will discuss about the message type that we are using in MLD version 1. So here if the message type is journal query, then what will happen? Here the destination address is added as a linked local scope of all nodes, and it is set to ff02:1. And if the message type is equal to multicast address specific query, then what happen? The multicast address that has been queried is added in the destination address. After that, if a message is a report message, then here the destination address will have a multicast address that have to be reported. And then done message, here if it has a done message type, then what will happen? The destination address will contain the link local address of all routers, and it will set to ff02:2. The next we will discuss about the MLD version 2. Here the MLD version 2 has a ability where node can do source filtering. So this is the difference between the MLD version 1 and version 2. It has the same similarities, but this is the one difference, that here it has ability where node can do a source filtering. So here what is source filtering? So here source filtering means either listening to packet with a particular multiple address from only specific source address, or from all source except from the specific source addresses. So here a list will contain a source addresses of a nodes that are present in multicast group, and here it will decide whether to send the packet to a particular devices that are added in the list, or not to send the message to that devices that are added in particular list. So here it will have a combination of SSM and ASM. So here SSM is source specific multicast and ASM is any source multicast. So there two filter modes are used that are supported by SSM are include and exclude. So here if it is include, it will include source address listed in source list are enabled to receive the packet. That means they are unable to receive the packet that have their name in source list. And in exclude process, here in this mode, all addresses except that listed in source list are unable to receive the packet. It means the devices that that are having a address in the source list will not receive that particular packet. They are excluded from the services. Now this is a packet of MLD version 2. Here it is also of 32-bit, but it is a long packet which will have a field of type, code, checksum, maximum response delay, and reserve and multicast. After that, the new fields are added over here, that is reserved, S field, QVR field, QQIC field, and the next one is number of source addresses. And after that you have to add the source address, that and the number of source address you are having, you have to add the address of that particular node source addresses. Starting with the first, the type field. So here the type field will have a value of 130 or 143. So here if it will have a value of 130, then it is a multicast listener query, and if it has a value of 143, then it will have a multicast listener report version 2, and it is defined in RFC 3810. Next bit is reserved, and this bit is reserved and set to 0. Next is S flag. So here the S flag is a suppress router side processing, and it is of 1 bit. And here when S is equal to 1 or it is set, then here it suppress the normal timer update at receiving multicast router side upon hearing a query. So here what will do, it will suppress the normal timer update of the router. After that, QVR field. Here QVR field is a courier robustness variable, and it is of 3 bit. Here when it is non-zero, it will contain the robustness variable value used by the courier. So this value affect timer and number of retries. So it includes queries in order to synchronize all the MLD version 2 router connected directly over to the same link. Then is QQIC, that is a courier query interval code. So this is of 8 bit, and it will specify the query interval that is used by the courier for the synchronization. And next is number of sources field. Here it is 16 bit, and it is represented as N, and it will specify how many source address are present in query. And when it is set to 0, it means it has a journal query and multicast address specific query, and when it is set to 1, it means it has a multicast address and a source specific query. So in source addresses, it is of variable length, and it will contain source addresses of a node, and here the length is specified by the number of addresses specified in a N field. Next we will discuss about the type of query. So here there are 3 types of query: journal query, multicast address specific query, and the multicast address and source specific query. The first one is journal query. So here it is it is sent by the queries to get the information about the which multicast addresses have listener on a attached link. So it will get the information about the multicast addresses that have a listener over a same link, and it will have a multicast address and a number of source field equal to 0. Then is multicast address specific query. Here it will give the information about if particular multicast address has a listener on a attached link or not. So here the multicast address field and multicast address of and the number of source field will have equal to 0, but here the multicast address field will have a multicast address of a node that will having that are over a same link. Last one is multicast address and source specifier query. Here it will give the information about if any of the source from the specified list of a multicast address has any listener over a attached link or not. And here a multicast address field will have a multicast address of a particular devices, and number of source field will contain the address of a source field, address of a source device. After that, the next part is multicast router discovery. So here multicast router discovery is used to search multicast router over a network, and it is defined in RFC 4286. So it doesn't have any specified routing protocol. So here we will use the 3 messages type, that is first one is multicast router advertisement, and next is multicast router solicitation, and last one is multicast router termination. So multicast router advertisement is used when a message is sent by router to advertise that IP multicast is forwarding as enabled. So here it is sent from a link local source address to all snooper multicast addresses. Then is multicast router solicitation. This message is sent by device in order to solicit advertisement message from multicast router, and it is sent to all router multicast addresses. Next is multicast router termination. This is sent by router to advertise that it stops IP multicast routing function on a interface, and here the multicast router discovery message are sent with an IPv6 hop limit equals to 1, and it will contain the router alert options. So this is all about multicast router discovery. So here we will discuss about the multicast listener discovery as well as multicast router discovery. So this is all about this concept. Thank you.